Welcome to Engineering Scale Models. I'm Jason, your host, and I do models. We are looking at a circuit here that is going to be an input for some logic chips. I was having some issues. I showed you in a previous video about the buttons, how you push the buttons, and I'll just show you here real quick. Turn the power supplies on. You push the buttons and the LEDs light, and the current flows. And then if you tap off one of these buttons here to go to an output of a TTL chip, just like this green one here, if I push this, I'm only getting 2.9 volts, and that's pretty close to the minimum that is needed to drive a TTL chip high, after a high signal for a TTL chip. And then if I do the blue, it is 2.1 volts, which is actually under what a TTL chip can read. So it may read it slightly, but it's a little bit under what it needs to be. This meter in the top corner, that's a singlet SDM3045X, and the power supply I'm using is an SPD3303XE by Singlet. It's fantastic test gear. It's all my test gears. That test gear, you'll see it in many videos. So as you can see, 2.1 volts. So I set up this circuit here with my 4 inputs, and I have this chip in here, and it is a, let me try to fix this exposure a little bit. Okay, and turn the meter off. It is a Intersil CA3046. It has basically 5 transistors, but one set's a differential pair. It's just a general purpose NPN transistor array. So I am going to attempt to use this. I haven't tested this circuit, I just hooked it up. Let me show you how I hooked it up here. I hooked up if you look here, I hooked the green LED up to the base of pin 2, and then pin 1 is going to VCC 5 volts, and then the emitter pin 3 is going to ground through a 1K resistor. And then I skipped this transistor here, and then the blue one is going to pin 6, the base of pin 6, and then again the collector is through a VCC and the emitter through a 1K resistor. And then I did the same for the red button is pin 9. Nope, the yellow button is pin 9, and then pin 12 is the red button, and again a 1K resistor between the emitter and ground, and a VCC coming into the collector. So my goal is to tap off at the point where the resistor and the pin. So I'll take a tap off point at pin 3, pin 7, pin 10, and pin 13 to see what I get voltage wise, and hope this works. Like I said, I haven't tested this. Let's put the meter back up. So as reference to ground, and I said, let me get my paper back, so pin 3 should give me something when I press the button. So if I come in here to pin 3 and I press the button, I only get 2.2 volts. Okay, that seems to be exactly what I was getting. What am I getting across the resistor? And 2.3 volts. So my question is, see, I don't want to run it straight to ground. Okay, so that's 2.2. Let's just check this one over here. This one is here at 1.3 volts. So apparently these transistors need to be driven higher, a higher milliamp range maybe, to drive these. Let's see what happens when we change the resistor between to 220 ohms here. Let's find the clippers. Let's grab a, because I'm using a 470 ohm resistor. Let's change it to a 220 ohm resistor and see if more current is the problem. Because normally it's a little, normally with a transistor you have a little bit on the base for a larger on the collector emitter part. So let's go back to this one, and that was 2.9 before. That's 2.2. So okay, let's see what this looks like with a lower resistor. No, that didn't change anything, so I'm going to put my 1K back in there. So it does have 5 full volts at the collector, and then the base well, let's see how much current is flowing between this pin 2. Let me mark that with this wire so I know. This pin 2. So I'm going to get out my current probe over here. Get my current probe. I'm going to swap this to my current probe. See, I have a current probe here, and then I'm going to switch this to DC current. And make sure I remember to check and change it back. Alright, so I'm going to put this one into pin 2. I'm going to put this into here, and we have a current of microamps. Literal microamps. Huh. That's pretty low. I don't think that's enough to turn that on. What if I come down here and I put and I tap off before the resistor, which I thought I did. No, it's still microamps. Now, if I measure the actual circuit of this LED circuit, it is lighting the LED, it is 219 milliamps. It seems like a lot going through that. Oh, went to the wrong spot. So it's like 13 milliamps. So there's 13 milliamps in that circuit, but with the going into the base of the transistor is only 35 microamps. And that's not enough. I need more than that. I'm not quite sure how that... I am going to get the data sheet. I thought this was going to be a simple... Because I did this with a BJT transistor and it worked just fine. Keep a book of data sheets of everything that I am using at the moment. So let's set this circuit aside. Let's take this out. Let's take off the current probe. Well, no, we'll leave the current probe on because I want to measure the current in a minute. So let us take a look at the data sheet. So we saw this section here. It's 5 general silicon NPN transistors, already colored. 2 transistors, differential connecting pair. Well suited in low power systems, that's what I was looking for. But the amplification, custom design differential. And then it says collector, maximum value, collector to volts, emitter 15 volts, collector to base 20 volts. Yeah, that's fine. We're not going to be doing collector current is 15 milliamps. We're going nowhere near that. Breakdown voltage. See here. Three milliamps. There is collector to base breakdown voltage, current cutoff to collector base 40. Okay, so a 3 volt collector to emitter, and then it's 1 milliamp. That's not. There is what I want to the base. Current. I want to see the output ratio. I'm not seeing. Just not what I was looking for. Yeah, I'm not seeing anything on here. Maybe you guys saw it and you can leave a comment down below and see if you can tell me. I'm looking for what the test condition was to base to emitter current. What does that need to be? What is the base voltage and current need to be to turn on the transistor, like to just completely turn it on. The max you can put into the base to emitter to base backwards voltage is collector to base voltage 20 volts. Okay, so emitter base 1 milliamp equals 10 milliamps out. So I wasn't even putting in a milliamp. So I need to find out why I'm not getting a milliamp put into that circuit. So let's try something here. I think I may have a reason why this didn't work. I'm going to go back to my 470 ohm resistor and I'm going to plug it in just like so. Plug that in like that, and then I am going to make sure this is in shot, and I'm going to take my current and I'm going to plug it into this section here, and then I'm going to plug it in to the base. That is number 2, right? Yeah, number 2, and then I'm going to turn back on my meter so you can see this, and I'm going to press the button and do it again. No, it's still 40 milliamps, 40 microamps. Yeah, I'm not sure. Alright, I'm going to chalk this up as a fail. Maybe this chip can't be used in the manner that I want to use it. So again, this was a chip CA3046, Jamico part number 12079. I thought it was just going to be like a standard NPN general purpose transistor, but I may have been mistaken. I'm going to mess around with it off camera. If it ends up working, I'll add a segment to the end of this video, but that's going to do it for this video, guys. I'm sorry that this didn't work out. If you guys know what the problem was, leave a comment down below. Let me know what I did wrong, and maybe I can revisit it and come back and figure it out. Thank you so much, and have a fantastic day.